morning, good afternoon, good evening, wherever you may be watching this from. This is Cornelius Lubinda with another video. So in the previous question, in question A, which said draw the graph, question A which says write the vector equation. We wrote the vector equation right there. We found by using the proper methods as stipulated, as I explained. We started by first of all using the gradient. Then we noticed that the direction vector is the opposite of the gradient. Alright, so that's what we came to note there. And this is what we found as our vector equation. Now they want us to draw the graph. They just want us to draw a line connecting point A and B. So point A is 1, 4. 1, 4 is somewhere there, like that. Then point B is 3, 1. Point B is simply 3, 1. So we have been given two coordinates like that. Then we'll just carry on with connecting these 2 points. Drawing a line that connects these 2 points. Alright, so it would be something like this. So that's how the line would look. But after writing the line looking like that, it is still not enough, because what we have forgotten is we need to name the line, okay? But it's okay, since they just said we draw the graph. So this is the graph connecting, this is the graph of the line, right? A graph is just putting it down on paper. So we have drawn the graph connecting these 2 points. Then question C says, draw a closed triangle that represents the vector equation using points A and B. So the formula for the vector equation is, for example, we have vector R, it is equal to R naught plus T direction vector M. R naught representing the position vector, then this representing the direction vector. Okay, so this R right here is called a resultant vector. A resultant vector, it comes about as a result of adding 2. So 2 or more vectors. So here this R naught is a vector, and then this M, forget about the T, but this M is also a vector. This T here, this parameter, is just used to increase or decrease the direction vector, or to increase the more we are moving away from this. So for example, if the coordinate is here, and then it's like that, the coordinate is there, it can be shifted by a certain direction vector, and it will find itself here. So maybe, for example, if the direction vector is 2, 1, and then we say 2 times 2, 1, it becomes 4, 1, like that. Okay. So, if that's still confusing, I mean multiples of the direction vector is T. So to draw the closed triangle, since we know A is a position vector, B is a position vector, we just draw vectors like this. So this is supposed to be a straight line, and this is also a straight line, like that. So this is the vector with an arrow like that, and upon us drawing it like that, it means that we have drawn a closed triangle. It means that if we are here, we need to move like this to there. So you can name any of them your R naught, and any of them you can name your resultant vector R. What I mean, this coordinate can come about as a result of this vector. You add a certain direction vector. Alright? So this is 3, 1. Now for us to move from 3, 1 to 4, 1, so 3, 1 minus 4, 1 is where we have ended. 1, 4. 3, 1 minus 1, 4 is here 2, and then here negative 3. So it means for us to move from this coordinate to that coordinate, we are moving by this, and this is called a direction vector. Now this direction vector that we are looking at is a 1. So what I mean is this: we can have a 3, 1 as a coordinate like that, plus t. Now t we know is a 1, alright? When t is 1, then we do that. So it will be 3, 1 plus 2, negative 3, right? I don't know if that's clear. So this is 3, 1, and then we add this particular direction vector to negative 3. That's what this is trying to tell us. What is the t here? So of course this is a t. This is just an example of how we need to know to find t. So this is the closed triangle. Alright. Thank you so much for watching. This has been Cornelius with another video, and bye bye.